Imagine a block of metal no larger than a beach ball. Yet inside it lies a source of energy powerful enough to snap the spine of an entire modern city. We are talking about the nuclear bomb, a weapon that forever changed humanity's definition of destruction. To truly understand it, we should not look at the colossal explosions portrayed in movies, but instead peer deep into the heart of matter itself, where atomic nuclei tremble under pressures the naked eye can never perceive. The principle behind a nuclear bomb, also known as an atomic bomb, is based on a concept that sounds deceptively simple but is unimaginably brutal: fission. Think of it this way. You start with an atom of uranium-235 or plutonium-239, which is inherently unstable. When a neutron is fired into its core, the atom splits apart. But the terrifying beauty lies in what happens next. When it breaks, it not only releases energy, but also ejects additional neutrons. These neutrons then slam into neighboring atoms at incredible speed. In less than a millionth of a second, a chain reaction erupts, multiplying its power billions upon billions of times. This is no longer a conventional chemical reaction between molecules. It is the release of the binding energy of the universe itself. Let us imagine a hypothesis to make this clearer. Suppose we could slow time and observe the moment the bomb known as Little Boy was dropped on Hiroshima in 1945. In the first millionth of a second, as the chain reaction reaches its peak, the temperature at the center of the explosion instantly rises to 60 million degrees Celsius, hotter than the surface of the sun. The surrounding air is compressed so violently that it becomes a glowing mass of plasma, incinerating everything within sight. At the closest distances, organic matter has no chance to burn into ash in the conventional sense. It is vaporized, transforming directly from solid into gas almost instantly. What remains are only dark silhouettes burned into concrete or stone walls, silent evidence of human existence completely erased by the power of the nucleus. So why does such a small piece of metal possess such horrifying power? The secret lies in the iconic equation of physicist Albert Einstein. Energy equals mass multiplied by the square of the speed of light. A tiny amount of mass lost during the fission process is converted into an enormous amount of energy. However, these early atomic bombs had a physical limit they could not overcome. If you tried to pack too much uranium into too small a space, it would reach critical mass and detonate spontaneously before you could trigger it on command. This posed a brutal challenge for scientists in the arms race. How do you create an explosion thousands of times more powerful without being constrained by the physical limits of critical mass? That question led humanity to a threshold far darker and far more powerful. It was the moment when humans stopped trying merely to split atoms and instead began learning how to imitate the very process that allows stars to burn across the vast universe. You must remember, the atomic bomb we have just analyzed, as devastating as it was, served merely as a small detonator for a far greater monster waiting in the shadows. The destruction witnessed at Hiroshima was only a spark, and a modest beginning compared to what would follow when two atomic nuclei are forced to fuse under unimaginable pressure and temperature. We are talking about the transition from fission to fusion, from division to a deadly union. When a nuclear bomb explodes, it releases an intense burst of gamma rays and X-rays. In later thermonuclear weapon designs, scientists used the immense energy from a fission bomb to compress a core of hydrogen fuel placed beside it. This was a bold and terrifying leap of logic, using one nuclear explosion to ignite an even larger one. Power was no longer measured in kilotons of chemical explosives, but in megatons, millions of tons of TNT. A single bomb could now do more than erase a city. It could alter the climate of an entire continent and wipe out all traces of civilization across vast regions. So in the moments ahead, we will explore the secrets hidden beneath the shell of the thermonuclear bomb. The weapon known as the ultimate weapon of mass destruction. Why does it have no theoretical limit to its power? And why do scientists call it a design worthy of gods, yet one that breathes the air of hell itself? Prepare yourself, because we are about to enter a world of temperatures reaching hundreds of millions of degrees and pressures capable of crushing even the most stable atomic structures. The destruction caused by the atomic bomb that we examined in the previous section represents only the first level of the nuclear nightmare. To create a weapon with virtually unlimited power, scientists had to turn to a source of energy far greater: fusion energy.
This is the culmination of
This is the same process occurring in the core of the sun and distant stars. Instead of splitting heavy atoms apart, we force extremely light atoms to merge together. But this immediately presents an enormous physical challenge. Atomic nuclei all carry positive electric charge, meaning they repel each other violently, like the identical poles of two magnets. To force them to fuse, you need temperatures and pressures so extreme that no conventional machine or furnace on Earth can produce them. The solution to this seemingly impossible problem was the birth of the Teller-Ulam design, one of the most closely guarded military secrets on the planet. Physicists arrived at a bold and almost insane idea: use an atomic bomb itself as the detonator for a far larger bomb. Inside the casing of a thermonuclear weapon, also known as a hydrogen bomb or H-bomb, there are essentially two main components, physically separated yet tightly linked. The first is a conventional uranium fission bomb. The second is a fuel core containing hydrogen isotopes, such as deuterium and tritium. Now let us reason through the sequence of events unfolding inside that cold steel shell when the doomsday switch is activated. First, the fission bomb in the upper stage detonates. Within a billionth of a second, it releases an immense burst of X-rays and gamma rays. These are not ordinary light waves. They carry pure destructive energy. The radiation reflects off the bomb's specially designed casing and focuses its force inward, compressing the second chamber that contains the hydrogen fuel. Pressure instantly rises to billions of atmospheres, crushing the fuel to less than 1% of its original volume in a fraction of a second. At the same time, temperatures soar into the hundreds of millions of degrees Celsius. Under these conditions, all physical barriers collapse. Hydrogen nuclei collide at extreme velocities and fuse together, releasing torrents of ultra-high energy neutrons. This is the moment when humanity truly brought a fragment of the sun down to Earth. This leads to a crucial question. Why is a thermonuclear bomb considered to have no theoretical limit to its power? In an atomic bomb, packing too much uranium together causes it to reach critical mass and detonate prematurely. But in a thermonuclear weapon, hydrogen fuel is completely stable under normal conditions. You can add as much fuel as you want, make the bomb the size of a truck, a building, or even an entire ship. And the explosive yield will increase exponentially, without encountering any fundamental physical limit. That is why the bomb dropped on Hiroshima, with an explosive force equivalent to about 15,000 tons of TNT, pales in comparison to the most powerful weapon ever detonated, the Soviet Tsar Bomba, which released the equivalent of 50 million tons of TNT. In less than 2 decades of development, its power exceeded its predecessor by more than 3,000 times. To grasp the scale of this devastation, imagine it visually. If Tsar Bomba were detonated, Its fireball would reach 8 kilometers in diameter, large enough to engulf the entire center of the world's most crowded megacity. The thermal radiation from the blast could cause third-degree burns to anyone standing more than 100 kilometers away. The immense air pressure would flatten even the strongest reinforced buildings within tens of kilometers, as if they were made of paper. But the most terrifying aspect is not merely the heat or the immediate shockwave. Fusion reactions release an enormous number of high-energy neutrons at unprecedented densities. If the bomb's core is surrounded by a layer of natural uranium, these neutrons will trigger a third stage of fission. This is known as the fission-fusion-fission process. It transforms the bomb into a massive radioactive fallout generator, capable of spreading radioactive debris around the globe through high-altitude winds, sowing disease and death for decades to come. The emergence of thermonuclear weapons completely transformed humanity's strategic thinking and its approach to survival. We are no longer building weapons to win wars in the traditional sense. Instead, we are building weapons capable of ending all wars by annihilating both sides simultaneously. This cold logic gave rise to the doctrine of mutually assured destruction. When a single bomb can wipe out an entire state, the line between victory and defeat disappears entirely.
Send the codes.
The thermonuclear bomb is no longer merely a military weapon for resolving conflicts. It has become the ultimate political instrument, a shadow looming behind every negotiation, every handshake between the world's great powers. We now live in a world where thousands of such thermonuclear warheads sit ready in launch silos, awaiting only a confirmation order to be unleashed. Power stolen from the sun rests in the hands of flesh and blood humans. In the next section, we will explore the long-term consequences the world could face if the worst-case scenario becomes reality: nuclear winter. What happens when thousands of these artificial suns detonate simultaneously in the sky? Can Earth heal wounds this deep, or will we plunge into a new man-made ice age born of our own hands? Together, we will unravel the doomsday scenario and humanity's final attempts to control the nuclear monster it has unleashed from the iron cage of science. If parts 1 and 2 showed us the immediate destructive power of steel shells carrying cosmic energy, then this third part takes us to a far darker scenario: the collapse of the entire global ecosystem. Imagine a situation in which thousands of thermonuclear warheads launch simultaneously from their silos. The world's greatest cities burst into flames, but that is not the end. The massive fires raging through urban centers and industrial zones would generate millions of tons of ash and thick black soot, carried upward by rising columns of hot air. This debris would be injected into the stratosphere, where there is no rain to wash it away. There, this black veil would spread across the atmosphere, blocking up to 90% of sunlight from reaching Earth's surface. This is the phenomenon scientists call nuclear winter. Consider what a world without sunlight would look like. Within just a few weeks, global temperatures would plunge to -20, even -30 degrees Celsius. Continents would freeze solid in the middle of summer. Photosynthesis would grind to a halt, triggering a cascading collapse of the food chain. Agriculture would disappear, water sources would freeze, and humanity would face a famine on a scale never before seen in its history. A critical question arises: could humans survive in underground shelters? Possibly, but it would be a bitter existence beneath the darkened earth, while the world above slowly dies. And when the radioactive dust finally settles after many years, another danger would emerge. Thermonuclear explosions would have severely damaged, if not destroyed, shocked the ozone layer, the shield that protects life from the sun's lethal ultraviolet radiation. When clear skies eventually return, they would not bring renewal, but radiation capable of causing genetic mutations and cancer in any organism that dares to step into the light. Earth would become a strange and hostile planet, no longer hospitable to the civilization we worked so hard to build. Yet even in the shadow of apocalyptic scenarios, we must look at the reality of human restraint. Why has no nuclear weapon been used in war since 1945? Because the doctrine of mutually assured destruction created a grim balance of fear. World leaders understand that pressing the launch button is not an act of attack. It is an act of collective suicide. This realization led to a series of arms reduction treaties, and in which nations agreed to dismantle thousands of warheads to pull humanity back from the edge of the abyss. We have learned to coexist with this monster by imprisoning it within political rules and strict international oversight. However, the threat has not disappeared. It has merely changed form. The emergence of hypersonic missiles capable of penetrating any defense system, and the risk of nuclear weapons falling into the hands of terrorist organizations, continue to push the doomsday clock closer to midnight. Reflect on this reality. Nuclear weapons are the only tools humans have ever created that can completely erase their own existence in a single afternoon. We have unlocked the secrets of the atom and grasped power once attributed to gods. Yet we still have not learned how to eliminate hatred and mistrust between nations. Looking toward the future, the true survival challenge is not about who possesses more warheads, but about ensuring they are never used. Nuclear technology is not only darkness, it also holds the promise of nearly limitless clean energy. If we can tame fusion reactions in civilian reactors, transforming the fire of demons into light for humanity. The line between an era of prosperity and a permanent nuclear winter is as thin as a single wrong decision. When we reflect on the entire journey, from tiny grains of uranium to thermonuclear explosions that shake the planet, we realize that nuclear weapons represent the ultimate test of human intelligence and morality. We are smart enough to create artificial suns, but are we wise enough to keep them from burning down our own home? The answer does not lie in laboratories or missile silos, but in our collective understanding of the value of peace and the fragility of our blue planet. We have only one Earth, and in a nuclear war, there will be no winners left to write the next chapter of history. The silence of a post-nuclear world would be absolute, a silence in which even the echoes of the past no longer exist.